Hello and welcome to the stream again. I had a brief one where it wasn't working, but now I can get the camera to work. And so this is just a live stream. I'm not going to do a lot of talking. Let me make sure that this is working. Must be a new stream. I have to go and how come it's dark here? What are we doing here? Oh, there we go. Oh, I messed it up. It's okay. Let's start the little thing here and okay. Okay, so let's get the TV set up. Which way am I looking? Let's put me in the lower right hand corner. Okay, so here we go. What we're doing right now is writing some sample code that I'm going to turn into a lecture. And I'm writing a dictionary object in C. That is an implementation of the Python dictionary object. And I've already written a bit of code that does a dictionary that uses kind of a classic linked list approach to dictionaries for keys and values. This is not actually using hashing, and so I'm going to basically build a key value store. This was one that used linked list, and I talked to Guido, and he told me he didn't use linked lists inside of Python. So now I'm rewriting it. So what I'm going to do is I'm going to make an array of key value pairs basically as my dictionary. Okay. So let's see where I made a lot of changes already on this. I think I have it working, right? So I got a little unit test here at the bottom. So, but when I compile it, it's the old school. It gives me segmentation fault. Let me make this bigger. Okay, so segmentation fault. So let's, wow, I don't even know where it's going to blow up. So let's just put printf a \n, printf b \n, and let's compile it again, see where we're at. It doesn't even make it through the new. So I'll printf 0 here. So my new code, let's just see if it says 0. Yep, okay, so it's in the new code. Let's take a look at the new code. Okay, so I'm going to allocate 8 key value pairs. And if we're going to, I think this is a array, or is that an array of, I think maybe what this might want to be is I think I want this to be an array of key value pairs rather than array of pointers to key value pairs. So let's try this. If this is an array, let's see. I don't know about that. Oops. I don't know. I think this is actually just, oh, items? Yeah. So if that's a pointer to a D node, then I can make it as long as I want. So I think I can turn this into an array. by allocating more of these things. P item sub I. Okay, so let's just save this and go a little farther, see if it goes. Whoa, that was not happy. Okay, so yeah, I meant to use dot on that. So I'm going to actually put the, so this actual GU dict is going to be basically 4, 8, 12. And then this is going to be pointing to a reallocatable array of items. So that means that all this arrow key stuff needs to turn into dot key. C2 space dot. Arrow value. So I'm making an array of key value pairs. Boom, 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 boom. Key value pairs. Let's see if that makes it better. Yikes. Self item sub I struct dnode star. Huh. So that is line 58 or 58? Not 58. That's line 69. So I think I'm not returning a pointer to a G node. So that's not right. This is going to return the item, the actual 2-element key value pair. Those pointers in it, but it's not itself a pointer. Let's see. And so if I take that out, that's going to be weird. I don't know, that doesn't make any sense. Gonna do this. I'm going to make the find return a pointer. I don't know why. That means I got to go like this. So I'm just going to return a pointer to that item in the array. Yikes. Oh, now that's a pointer. Line 77. Oh, this is a mess. Free old dot value. Dnode star. There's a pointer. 94. 94. Old is a pointer. So well. Okay. Something happened. And it didn't blow up. No. Okay, let's see what I got here. What's the 0, the A? I got some print stuff going on. Oh, that's 0, A, B, C. Okay, so let's get rid of that. Let's get rid of that. Get rid of that. Okay, so... Oh, I know why that's no. It might be exactly what I want. think it actually is just right. So null, 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 null. That's because I've got an array after I create it, and they're all the key value pairs are null, null, because when I first build it, I do this, and I set them all to null. I make 8 key value pairs. I set the key and the value to null, and so why am I not surprised when it prints out null, 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 null? Now the problem is I don't think I finished the put code, and so I think that I need to insert this. So I've got this new guy, and I need to say, and this is dangerous, but I think I'm supposed to say that self arrow items sub self arrow length equals new. So that's an array on the left that's going to resolve to a D node. New is a D node. Hi there. Hey, Corrupted Keep. Yeah, congratulations on using database and your certificate. I'm working on C programming for everybody right now, trying to build some sample code. Smash! That didn't work. Let's see. Self items at the length is new. What am I getting wrong there? Oh, new. No. Okay, so no. So problem is I'm going to end up with an actual D node here. So don't think I need that. Where's new? Where's new? New is a D node. I actually don't think. There's not. It's already there. Okay. So I need to create the new value in the new key. And I don't need this. I don't need that. So I can say self items length. Come back. Where are we? Input. Okay, so I save a new copy of the key and the value. Now I think I say key equals new key, and then value equals new value. The new value is like, I should call that saved value. Okay. So we've got to insert, we got to allocate, we got to copy the key and the value into newly allocated strings, and then we're going to add them at the end. And we're making a linked list now. We're not, I guess we're making an array of key value pairs is what we're doing. Let's see how far we got. Whoa. That looks really good, actually. Look at that. I think it might have worked. Huh. I think what I'm going to do is teach it not to print out the keys. I'm not going to print the nulls out. So what we got is we've got a dictionary. It's got 8 entries in it, all of which are empty. And so these are empty. Actually, I could just go up to length, really, because I haven't yet done any hashing. I'm thinking about adding hashing to this later. So if I go to the dump code, it really, where's the print code? It really needs to be less than self length, not self alloc, because it's got 8 things alloced, but it's only got a length here in this case of 1. It's got a 0. So I got a feeling that that's just going to work. That's the weird thing about these. Yeah. So if you look at the code, we're starting with an empty dictionary. Then we're saying Z maps to catchphrase, and then we replace it. Let's go look at that code. I can finally go look at the unit test. So put catchphrase in key value pair, then replace that, then add 2 more, 3 more, and then print it out. Okay. So that is working. Look at that. It works. I should probably say get status here. When G dictionary, git commit. So we're going to commit that. Now the question is, I got a totally good hash map. I have a totally good dictionary. I am not rehashing. Yeah, Linux for everybody. I'm not rehashing yet, so I can't handle more than 8. It's really just like a linked list. The question is, I like the simplicity of this code. And I like the simplicity of this code, and I like the sort of like equivalence between the list code and the dictionary code. Because this list code has got an alloc and a length, the dictionary code's got an alloc and a length, but then it's got, instead of just a pointer to characters, it's pointer to a key value pair. And that's really the only difference between this list and the dictionary. And this is how dictionaries and lists work in Python with 3.7 and later. And that's why what we're seeing here is we're seeing it come out in key order. So it went in as Z, Y, C, A, and that is the insert order. And so this is an order maintaining dictionary. Insert order maintaining, not a sorted dictionary, but an insert order maintaining dictionary. So the question is, what am I going to do about hashing? So I'll tell you what I think I'm going to do about hashing. I am going to make another copy of this. Copy GU dictionary to GU hash .c. I just like this dictionary that's just like it's like an array of pointers to array of key value pairs, 2 pointers per entry. I like it. So I'm gonna add hashing to it, and I'm gonna add it in a separate file in case I don't like what I end up with hashing. GU hash. Okay, so now what I need is I need some hashing code. So in here I think I've got some hashing code. Where is the hash? Hash. GU hash dot, no, that's the one I just made. It is map hash. Let's look at this one. No, that's scary. Grep hash star. Oh, that's way too much complexity. Oh, that's hash.c. Okay, so this is my hashing function right here. Boom. Let's go ahead and add this here. Okay. So basically what this will do is this will use a modulo and get us within the buckets. And I'm using a simple like shift by 3 and exclusive or shift by 3, which gives me a pretty random kind of thing. So now what I'm going to look at is the put. Actually, I'm going to look at the find. Got to look at the find. Okay. So, no, well, let's just go here. Let's say I comma bucket. And so I'm going to say bucket equals get hash key comma self alloc, which is I'll print that out. Key, comma bucket. Let's just see if that printout looks good, see if that compiles okay for me. What? Oh. I gotta change all these to DICT. So we're going to use a hash dictionary, which is different than a simple linear dictionary, because the dictionary is just a key value pair. The hashing has to do with quicker lookups. So this is a faster one, and you'll see how little real work I've got to do to make this different. Okay, so now I'm going to compile the hash code and run it again. It should be identical to my previous dictionary code. Get hash, where are we at? What did I get wrong there? Oh, get bucket. Boom. So we're looking for the key Z. It's in position 2. So I've got a bucket from 0 through 8, which is nice. All those numbers, all these numbers are from 0 to 8. So this would stay going to bucket 2, bucket 1, bucket 3, bucket 1, bucket 2, bucket 0. Okay. So, okay. So let's see how to explain this. Let's just make a blank presentation. So let me show you what's going on here. So we got these key value pairs. Just think of this little box as a key value pair. I'm going to have 8 of these. Let's just put K/V. Actually, no, I'm going to want to put some text here. Where do I put text? Okay, we're making some PowerPoint on the fly here. And we're doubling each time, so we're going to get PowerPoint done really fast. I'm not going to make it very pretty. We're just going to get this done. So what we got is an array. Okay. So we're going to start with an 8-element array, right? So if you take a look at the code here, I'm allocating 8 key value pairs, and that's what's in the pointer items. And so the first thing I'm doing is I'm just putting in 0, 1, 2, 3 as if it were a linked list. So the hashing function, what's going on here? Shapes. The hashing function is going to take a string. The string's going to run the hashing function, and then it's going to pick one of these things. So like if you look at the hashing function, it's not going to start at 0. So what we're going to do is we're going to put these things in. So the z goes in position 2. So that means when z goes into the hashing function, oh man, oh man, oh man, text box, z, give me a text box right there. Z, when we send a lowercase z into the hash function, no, just let me grab it. So we send a lowercase z in the hash function, and out comes a 2. So that basically says that instead of starting z at 0, we're going to start z at 2. And then we're going to look for z going down this way until we find a null. So recall that these are all null. So if this goes in and we find it, and we get to position 2, and that is null, I mean, if that one's null, we can use it. Otherwise, we're going to go down 1, and if that one's null, we're going to use it. We're going to keep it going down. Now, the key is we got to make a circular check. So when we get to 7, we've got to go back up to 0. So in this case, when z comes in, it's going to have to go 2, 3, 4, 5, 6, 7, 0, 1, 2. And in this, we're going to use modulo. We're going to use the fact that this is powers of 2, but we got to write a circular loop that starts at 2, and eventually we'll go and, because when you get hash collisions, then we're going to chain, but we're going to chain in this array. So I got to write a circular loop that starts at 2 and stops at 2. So let's go in and look at find. So where's find? So find's job, we're going to redefine how find works. Find is not just going to return null. It is going to loop through all the buckets, and it's going to return whichever bucket is null. Well, we're going to go until we find a null bucket, or we find a bucket that matches the keys. So if there is keys that all match to 2, there's going to be some 0 in here. So it'll be like 0, 0. That'll be the null. So like z, something will be in this one, there'll be something in this one. So we either have to match it or hit a null. And once we've hit the null, then we're going to return this one because that's the one we want it to put the new one in. Okay? Okay, here we go, here we go. So this for loop is not going to be like that. It is going to be for I equals bucket. So we're going to start at bucket 2, and then I not equal bucket. Oops, not, come on, not equal bucket. And we're going to say, come on, we're going to say I equals I plus 1, I equals parenthesis I plus 1 modulo self arrow alloc. I put extra parentheses in here because I like parentheses. We're going to add 1. Then we're going to modulo alloc, when in this case that self alloc is going to be 8. So I'm going to just say, here we go, we're going to say printf looping %d, comma I. So this key thing here is it's going to go down from bucket down until it gets past 7 in this case, because when it gets to 8, 8 is going to become 0 because we're going to do modulo 8. So it's going to be, this should be 2, 3, 4, 5, 6, 7, 1, 0, 1, 2. So it's going to loop through all of them. And if self items key is null, which means it's an empty and available, we're going to go, God dang it. Where am I? Where am I? I got so excited. I'm going to say printf returning empty at %d /n, comma I. And we're going to return self item sub I And if the one we're looking at, the key is null, we're done, and we've returned the next available empty spot to put the new stuff, or we've returned an indication that it's no good, that we didn't find it, or if we match the key, we're going to return that one. And in this case, we're going to put a print statement out. Could not find empty or matching key. Failure. Later, we will have to expand this. In this case, we've got a completely full hash map, which in this case, we're not going to have. And we're going to get a seg fault. We'll go ahead and return null, which is going to give us a seg fault in the next statement, okay? But that's not going to happen, because ultimately it is going to either return, let me make this, this is returning match. And that's failure. The point is, as we go through all 8 of them, either we're going to find an empty one or we're going to find one that matches. And if we don't find either an empty one or one that matches, we're out of space and can't put it in, which means we're going to blow up. And the return null will do that. So let's find this underscore find bit. Okay, so if retval equals null, or retval key is null. I'm doing this in the right order because this is a guardian. Come on. So this is a guardian pattern. If the retval is null, that means things went bad. If retval key is null, that means it's an empty entry. And we're in the get method, so we're going to return that we didn't find anything. We could have put a default up here if we were going to do that. And then if we did find it, we're going to return the value that we found. So that's all we need for get. Then what we're going to do here is we are going to find the old. If it's there, we found it, because that's the key. We're doing a put now. which might insert or replace. This is the replace case. If it's a replace, we're going to take the old value, and then we're going to allocate a new value, and we're going to just point to that new value after we've freed the old value and allocated a new value and done a string copy, and away we go. Now we have found it. So here's the key. What we're doing here now is we are not going to put it in self-length. We're not just adding at the end. We actually now have old, which is not null, and so we can say old key equals new key. We'll clean this up in a second. I hope it works. Old value equals new value. So we were adding. We'll still keep track of the length because we're going to need to know the length to know when to rehash. As we get a load factor above, say, 2/3, we're going to have to rehash. Okay? Okay. Who knows if this is going to work? Who knows if it's going to work? The camera's obscuring the code. Okay, the camera's taking the code off. There we go. Boom! Crash. Segmentation fault. Not good at all. So, is this code the solution of a problem? No, it might be. No, this is code I'm just writing to build what Guido van Rossum told me was the way he implemented dictionaries, and which I thought it was going to be a simple hash map, but it's not. It's open hashing. So I'm just building some sample code that when I get the sample code, I'm going to build a lecture for this sample code. And so it's not like it's the solution to any of the assignments. It's going to be part of the epilogue lecture for C programming for everybody. Okay, so we blew up badly. We did a find. I think we're doing the put here. So we did the, so it's, I think we're doing a put. Did it print out okay? Yeah, so it printed the empty list out okay. And then I was trying to insert one. So we're in put. Let's see. I'm just going to do this. I'm going to succinctify some of this. Oops. Oops, undo. Oh wait, if old is not equal, this is not quite right. Because old might not be null. We have to say if old is not equal to null and old key is not equal to null. Because we might be pointing at an empty entry in our database, in our thing. We might be pointing like at one of these that's got 0, 0. So the key's got to be null also before we go freeing old value, and this is the line that gave me the segmentation fault. Oh, it's all good old school segmentation fault. Blows up, just runs fast, blows up fast. Let's see what we got. Oops. Oh no. Okay. What did I do wrong? Stir copy. Oh. Okay, we're just going to call this. Oh. If I'm going to make the code more succinct, I've got to make it all more succinct and use the same thing when I get rid of variables. What the heck? What did I do wrong? Old is not equal to null. and old key is not equal to all. No. Printf found, is it %p/n, comma, old. Looking for %s looking for %s. Okay. I found it. Old's not null. Sterling value. We'll see. Let's see what I'm getting printed. Something might be just broken in my loop inside. I made that fancy. Look at her. Ah! Oh, do I have to cast that? Struct dnode star. What? Did I say void star? Is that going to make it happier? Oh, well, that's wrong. That's supposed to be key. Ha 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 ha! There's my horrible error message. We're looking for Z. We're looking for it in bucket 2. Oh man, oh, I know why. Let's go find my find routine. So the problem is it does the I equals bucket, I less than equal bucket. Shoot. So that I not equal bucket becomes false instantly because I is bucket. Okay. That is too tricky of a construct. Okay? So I'm gonna bucket. Bucket is where it belongs. We're gonna call this one like check. You'll see what I'm doing here. See. I just made this too complex. So I am going to just go from I equals 0 through 8. Then what I'm going to do is I'm going to say check equals I plus bucket modulo self alloc. Got to get this loop, right? So if it's going to be 2, and then that goes away. This is my check. Or maybe I should call this. I'm going to call that offset. And then I'm going to make the offset go from 0 through 7. And then I'm going to add offset plus the bucket. So we're going to, like, 0 is the bucket, 0 plus 1, I mean bucket plus 1, bucket plus 2, bucket plus 3, all the way to bucket plus 7. But then it's going to modulo, so it'll go back up. It's only going to run 8 times with an offset 0 through 7, but then the offset is going to be shifted down past the bucket. This is fun. This is old school fun stuff. Yeah. So then I just use I the rest of this place. And now I can compile hopefully again. No, what did I do wrong? What did I do wrong? Int, bucket, offset. What did I do wrong? What did I do wrong? Check, oh, check, check. Oh, that's supposed to be I. The I, the actual position in the array, which will be going 2 and then down, 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 then back up 0, 1, and then stop. I think I got it. Think I got it. By George, I think I got it. It's looking good. If we ever are we looping? Do we ever go upwards? Looping 2, looping 2, looping 1, looping 3, looping 1, 2, 3, 4. Found an empty one at 4. That's feeling pretty good. But now the question becomes. Oh, this is not going to be ordered now. This is not going to be ordered. But something's not right. We get null, null. Oh, I think I know what the problem is. This is the print statement now. So the print statement, no, that's going to go through all of them. Oh, no, I got to go through alloc. I got to go to alloc. I got to go all the way up to alloc. Because I got to go through all of them. And then if I say if self items I equals null, continue. So I think it's working, but I think my print statements, this is wrong because it's going up to length. It's got to go all the way through alloc, skipping nulls. I don't want to see the nulls. So let's run it again. Rawr! What? Oh, where am I? Where was that? Self items key is null. Continue. Come on. Yummy. Aha, look at that. Look at that. It's got the right stuff in it. All right, let's go delete all the print statements. Let's delete the print statements and have it print out really nice. Look at that. Z is catchphrase, Z is W, and it is a beautifully out of order hash order. It's a beautifully out of order hash order thing. Now, because I don't have any rehashing in this code, it's going to blow up when it gets too big. But I'm only putting 4 in and I got 8 spaces. So we got 50% load factor. But it is beautifully, like if I do this really quick, I find that code to do the prints, you will see, if I don't skip the nulls, you will see the hashing in action. You'll see that some of the entries are empty, right? So empty. So here we got like lots of empty. They're all 8 are empty. And now Z ended up in position 2, 0, 1, 2. So that's in there. And then Z got changed and it's still in position 2 because that's the hash position. I'm loving every minute of this right here. And then Y ends up in hash position 1, and Z is in 2, and then C is in 3, and A is in 4. And it seems to be working. So I'm going to just leave this print statement in. That would be a nice one to comment out from time to time when I'm demonstrating this, when I'm actually doing the lecture. So. So let's do this. Now, if I do this GNU, G-U-D-I-C-T, you will see an ordered dictionary in insert order. So you see how this is, that's in hash, the top one is in hash order, and this one is in insert order. And in this particular one, it is, in this particular one, it's not really doing hashing at all. It's really just a linear list of key value pairs. Just like if I do the list one, it's a list of it's just a list of strings. And so where am I at in Git? Okay, Git add gu hash.c, get commit -a hash version of Dido, D-I-C-T, git push. So that feels good. So I can make a third dictionary that is a combination of, so what we've got basically is the GU hash, this one right here, that's kind of like a Python 1 dictionary and a Python 2 dictionary and a Python 3 up to 3.6 dictionary. And this GUDict is a part, it's half of a Python 3.7 dictionary because it is in insert order, but what it's not using is hashing as quick index lookup. And if we do that, we actually need another quick hash table. Yeah, I think we need a whole separate index table. So I think I'll sleep on that one. So I guess I'll stop here. Thanks for the 4 people or 2 people that are still watching. This was just another experiment. I was working on this and I thought, I should have just streamed it. So that's what I'm going to start doing. Is I'm going to just start like writing some code. I sit and write in this office all the time. Oh, hey. Let me show you something. I just sit and write in this office all the time, and I'm going to start streaming. Look what I got. I just got this in the mail today. It's my 100,000 subscriber play button from YouTube. I got to put it up in the back. For now, I'm just going to just worship it for a bit. 100,000 subscribers on YouTube. That's pretty cool. Okay, put that back down. Okay, good night, everybody. See you on the next stream. Cheers. I'll end the stream.